Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video, the Power Series, is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended to view the video Introduction to Infinite Series prior to watching this video. In this video, we will be discussing the definition of a power series, convergence of a power series, and a series as a function. If x is a variable, then a series of the form, the sum from k equals 0 to infinity of a sub k times x to the k equals a sub 0 plus the sum from k equals 1 to infinity of a sub k times x to the k equals a sub 0 plus a sub 1 times x plus a sub 2 times x squared plus a sub 3 times x to the third, and so on, with the coefficients a sub 0, a sub 1, a sub 2, a sub 3, and so on, is called a power series in X, or a power series centered at 0. Similarly, the sum from k equals 0 to infinity of a sub k times x minus c to the k equals a sub 0 plus the sum from k equals 1 to infinity of a sub k times x minus c to the k equals a sub 0 plus a sub 1 times x minus c plus a sub 2 times x minus c squared plus a sub 3 times x minus c cubed, and so on, where c is a constant, is called a power series in x minus c, or a power series centered at c. Given a power series, the sum from k equals 1 to infinity of a sub k times x to the k. Such a series may diverge or converge for certain values of x. For example, suppose the sum from k equals 1 to infinity of a sub k times x to the k is a series of non-zero terms for k greater than or equal to 1. If x equals 0, the series converges to 0. For x not equal to 0, we determine an interval centered on 0 where the series does converge. If the sum from k equals 1 to infinity of a sub k times the quantity of x minus c to the k power is a series centered at c and is a series of non-zero terms for k greater than or equal to 1, if x equals c, the series converges to 0. For x not equal to c, we determine an interval centered on c where the series converges. For example, let's evaluate the series, the sum, from n equals 1 to infinity of negative 1 to the n plus 1 times the quantity of x minus 5 to the n over n times 5 to the n. We can evaluate this using the ratio test, which states that if the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n is less than 1, then the series converges. Therefore, we take the limit as n approaches infinity of negative 1 to the n plus 2 times the quantity of x minus 5 to the n plus 1 over n plus 1 times 5 to the n plus 1, all over negative 1 to the n plus 1 times the quantity of x minus 5 to the n over n times 5 to the n. First, we reverse our fraction and work towards canceling terms. The quantity of x minus 5 to the n plus 1 over the quantity of x minus 5 to the n gives us x minus 5. Negative 1 to the n plus 2 over negative 1 to the n plus 1 will just leave a negative 1, which we can express as just 1 when it is inside the absolute value. 5 to the n over 5 to the n plus 1 leaves us 5 in the denominator. When we simplify, we are left with the limit as n approaches infinity of the absolute value of n times the quantity of x minus 5 over 5 times the quantity of n plus 1. Next, we separate out the n terms to get the limit as n approaches infinity of the absolute value of n over n plus 1 times the absolute value of x minus 5 over 5. The x minus 5 over 5 portion is not involved with the limit, so we take a look at the limit as n approaches infinity of n over n plus 1. We can solve it by multiplying both numerator and denominator by 1 over n to get the limit as n approaches infinity of n over n, all over n over n plus 1 over n. N over n will go to 1, and the 1 over n will go to 0, leaving us the absolute value of 1 over 1 plus 0, or 1. This leaves us 1 times the absolute value of x minus 5 over 5. Next, according to the ratio test, if the absolute value of x minus 5 over 5 is less than 1, then the series converges. We can solve this by multiplying each side by 5, then resolve the absolute value into the two inequalities x minus 5 is less than 5, and x minus 5 is greater than negative 5. We simplify these into x is less than 10 and x is greater than 0. Then we combine this into the compound inequality 0 is less than x is less than 10. Next, we must check the boundary values for convergence, meaning we check the series when x equals 0, when x equals 10. For x equals 0, the series becomes a sum from n equals 1 to infinity of negative 1 to the n plus 1 times 5 to the n over n times 5 to the n. We can simplify this first by splitting negative 5 to the n into negative 1 to the n and 5 to the n. The 5 to the n's cancel, and we can multiply negative 1 to the n plus 1 times negative 1 to the n to get negative 1 to the 2n plus 1. 2n plus 1 will always create an odd exponent, so this is equal to the sum from n equals 1 to infinity of negative 1 over n. This is the negative of the harmonic series which diverges, so the original series diverges at x equals 0. For x equals 10, we start with the sum from n equals 1 to infinity of negative 1 to the n plus 1 times 5 to the n over n times 5 to the n. The 5 to the n's cancel, leaving the sum from n equals 1 to infinity of negative 1 to the n plus 1 over n. This is the alternating harmonic series which converges. So the original series converges for x equals 10. Therefore, the interval of convergence is 0 is less than x is less than or equal to 10, or interval notation 0 to 10. The power series, the sum from k equals 0 to infinity of a sub k times x to the k, defines a function, or f of x equals the sum from k equals 0 to infinity of a sub k times x to the k, which equals a sub 0 plus a sub 1 times x, plus a sub 2 times x squared, and so on, including a sub n times x to the n. The domain of this function is the interval of convergence of the power series. As an example, let's evaluate the function as defined by the series f of x equals the sum from k equals 0 to infinity of x to the k over 3 to the k. The domain of this interval is the convergence of the power series that defines f. First, we look at the exponent and rewrite the series as the sum from k equals 0 to infinity of the quantity of x over 3 to the k power. This is the geometric series of the form the sum from k equals 0 to infinity of r to the k, where r equals x over 3. This series will converge when the absolute value of r, in this case equaling the absolute value of x over 3, is less than 1, or negative 3 is less than x is less than 3. Therefore, the domain of f is a set of all x such that negative 3 is less than x is less than 3, or using interval notation, negative 3 to positive 3. For a geometric series, if the absolute value of r is less than 1, then the sum from k equals 1 to infinity of a times r to the k minus 1 will converge at a over 1 minus r. Therefore, a series which can be expressed as a sum from k equals 1 to infinity of x over 3 to the power of k minus 1 fits the form of the geometric series where a equals 1 and r equals x over 3. This gives us 1 over 1 minus x over 3, which simplifies to 3 over 3 minus x. The function can now be solved for any x in the domain negative 3 to positive 3. For example, f of 2 equals 3 over 3 minus 2, or 1. F of negative 1 equals 3 over 3 minus negative 1, or 3/4. Our next example is similar, except we'll evaluate a power series not centered at 0. f of x is equal to the sum from k equals 0 to infinity of the quantity of x minus 2 to the k over 3 to the k. This is a power series centered at 2. We can rewrite this series as a sum from k equals 0 to infinity of the quantity of x minus 2 over 3 to the k power. This series now matches the form of a geometric series, the sum from k equals 0 to infinity of r to the k, where r equals x minus 2 over 3. This series will converge when the absolute value of r, or the absolute value of x minus 2 over 3, is less than 1, or simplified to negative 1 is less than x is less than 5. We next remember that the sum from k equals 1 to infinity of a times r to the k minus 1 equals a over 1 minus r. To match, we can rewrite our original series to be the sum from k equals 1 to infinity of the quantity of x minus 2 over 3 to the k minus 1. In this case, a equals 1 and r equals x minus 2 over 3. We then determine our geometric series equality as 1 over 1 minus x minus 2 over 3. We simplify by multiplying the numerator and denominator by 3 to get 3 over 3 minus x plus 2, or 3 over 5 minus x. Now, any value in the domain may be calculated. For example, f of 0 equals 3 over 5 minus 0, or 3/5. f of 2 equals 3 over 5 minus 2, or 1. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.